Welcome to the Databricks Skill Builder series. We're glad you're here.
Okay, well, good afternoon, everyone. It is noon Central, so time for our lunch and learn. If you're elsewhere, maybe you can still have a snack, something to drink. I'm Mimi Quinnell. I'm a solution architect at Databricks. I am in the Chicago area where it is currently raining and sleeting, but at least it's not snowing like in Minneapolis. I am a solution architect at Databricks. I've been here about 18 months. And at Databricks, if you know, we have market specialties. My patch of accounts and solutions is in the health and life sciences area. So I welcome everyone. Feel free to type questions in the chat. I'll do my best to see them. Sometimes that's hard to do when I'm presenting, but I'll do my best there. Okay, so I'm going to share my screen. Let's see if I can do that. Let's see, share screen. Okay. Today's topic is called working with nested data. And you may be wondering kind of where the title originally came from. I actually borrowed this from a session that was done over a year ago, and I'll get into that. Before I jump in, I want to make sure everybody has seen that we have an abundance of free training coming along in the next 2 months throughout March and April. These are led by our training teams with the goal of getting you and your teams to be onboarded and capable and ready to bring your use cases up. So this includes a single session called Lakehouse Fundamentals to get you oriented to the Lakehouse, some foundational hands-on training, onboarding sessions in specific topics, as well as platform administrator training. All of these, you can find them listed at, if you just go to databricks.com and you go to this website. If I can just go here, I'll show you where to find these schedules. But again, these are free, and it's a great way to get your teams onboarded pretty quickly. So if you just go to databricks.com/training home and you scroll to the bottom, you'll see a big listing of upcoming classes, and these are these foundational events. And you'll find the registration links. Some of the registration links for some of these are actually within Partner or Customer Academy. So if you're an existing partner, existing customer, and you have access to our online learning platform, within that platform, you'll be able to access some of those. So please, if you haven't, gone through these, they're free, they're available for you, so go for it. The other thing I want to bring up is the biggest event for Databricks of the year is held in June. It's the last week of June in San Francisco. It's both in person and virtual. It will, keynotes, breakout sessions, our product leaders, our architects, thought leadership sessions with, panels of industry experts, a chance to network with your peers, a full expo floor. You can register for this now. We also all just went through training on this. There are discounts available if you just reach out to your account team. If you want to send a large group of people from your company in person, there are group discounts. There's also just individual discounts we can offer you as your sales team. If you want to attend virtually and just stream everything to your team in your own room and in the safety of your own town, you can do that. And I believe that's completely free. But definitely reach out to your team to learn more. Let's just see. Do we have any questions? Why can't I see the questions? Where are my questions? Let me just make sure there's no questions on that yet. Okay, no questions there. Great. Okay, so today we're going to talk about nested data and how to work with it within the Lakehouse. So let's jump into that. The thing I wanted to point out is Databricks always has, in addition to the official training, solution architects like myself or Stephanie or Allison are always coming up with other ways to try to help you get the training you need. So about a year or two ago, there was a video session that was recorded and released to YouTube. It was called Data Collab Lab. And it was a group of solution architects that picked up different topics and released videos on them. So the session I'm giving today is actually a recap of a session that is already out there on YouTube. It's about a 48-minute session, but you can watch it on your own. This link is available to you all the time. It's called A Foray into Nested Data Using Spark SQL and Dark Chocolate. It was led by Lee and Franco. Franco is now one of the product leaders for our Databricks SQL product. You probably have seen him in many forums or even here teaching Databricks SQL. And Lee is a solution architect. So you can watch this at any time, and you'll be able to see the code that's used. I'm just going to do it live here in case there's other questions. So first of all, let's talk about just very briefly the Databricks Lakehouse platform. Remember, we are one platform that is trying to serve natively and in a very integrated way all of those key use cases. So first of all, a single source of truth for all your data, whether that data is logs or text, audio, video, images, or row and column tabular data. It's all going to exist in the cheapest, most scalable open storage system on the planet, which is Cloud Blob Store. So if you're in AWS, it's going to be all that's going to be in S3, or in Azure, it's going to be ADLS. In Google, it's going to be GCS. So we're always storing your data in files in this open storage system in open formats. So it's never locked away. On top of that, we have an access layer called Delta. It's actually a protocol to manage how those bits are compressed and stored in those files to make sure that that's optimal, to give you row and column granular access to it, to make it performant and reliable so that this lake doesn't become a swamp. On top of that, you have a unified governance layer, so you don't have to worry about the native cloud IAM permissions or giving everybody access to a bucket and how that works. You can just use simple SQL grant statements and revoke statements or usage statements on the different tables and databases that you create from these files. And then your different use cases can all run on that. So a single source of truth, a single governance layer, and performant access for all of your use cases, and all of these people can collaborate with the same tech stack. That's the value of the platform. So today we're going to talk about data that's stored in your cloud data lake that is deeply nested, and we'll talk about what that means and how you can access that and manipulate that with simple SQL, either in a notebook or in a SQL editor, a SQL workbench. So let's take a look at what this means. So structured data, let's look at two types, right? Flat and nested. So in flat data, you have rows and columns, and for each cell, you have a single data element. So in this case, we have a table. We have two columns, company and company location, and each cell is a single element. So Cacao Hunters, Colombia, Fossa, Singapore, etc. When you have structured data that's nested, it's still a row and column type of arrangement, but there's more than one data element within the cell. And it can be arranged in a number of different ways. You can have a data element that is an array, so like a Python list. You can have a data element that is a structure, so it looks more like a JSON dictionary, which is what I'm showing here. You could have a data element that is a string that represents an XML document, or a string that represents a JSON document. And you want to find a way to access the different elements in that structure or array or string, and how to manipulate it without necessarily needing to flatten everything. Like if I wanted to get a list, in this case, I hope you can see this. Let me bounce out of that and try to make that bigger. Whoops. Sorry. Let's try to zoom in here. Why won't it let me zoom? Sorry, I was going to try to make that bigger for you. My screen is not zooming right now. My goodness. And now my cat is whining. I'm not sure what just happened. Just a second. There we go. Let's try to zoom in there. It's not zooming. Okay, forget that. So all I wanted to try to say was, if I wanted to access into this JSON document and just do a select distinct of bean origin, I don't have to completely flatten this out with every column in it, with every element in its own column, and then do a select distinct on this. I can do it while it's still nested, and lots of other functions as well. And so we're going to explore what those functions are and how do we learn about it, right? So, okay. So the best place to start is to go to the docs. I know people don't like to go to the docs, but every time I read this document, I learn something new. I was reading it yesterday and discovered that we have native CSV functions, which will parse CSV from strings. I didn't know that was there. I had a customer last week ask me about how to parse XML documents or XML strings out of a column, and I suggested something to him, and I didn't realize that we now have XPath functions. So let's jump to this, and let me just check the chat real quick. I don't see any Q&A yet. Okay, great. Let me go back to sharing my screen. So let's look at what those built-in functions are. So this is that link I was just showing you. And, you know, honestly, I'm a geek. I think it's always interesting to see what's new. I think we all know basically how to use SQL, right? Select this from that. We know case statements or if statements or grouping and ag statements. We know the basic functions, but there's some higher order functions and higher order data types like arrays and structs. And then there's these other functions. So if we look at, for instance, array functions, an array resembles a Python list. So it's a list of similarly typed item with a numerical index. So I can have an array of 1, 2, 3 or ABC. They're all strings or they're all ints. And if I have I can say array, you know, item 0 or item 1, and it will return the item at that element. Well, in addition to being able to have an array as a data type, I have a bunch of different array functions. So I can say, does my array contain a particular value? Or can I deduplicate my array? In a single command, I can do that. I can deduplicate my array. Can I return the intersection of two arrays? So that can I return the minimum element in an array or the maximum element in an array or the position of a particular element? There's all these functions here to manipulate arrays, and we'll go through some of them, right? But this is just arrays. There's also map functions. Maps are I think of them like lookup tables. So it almost looks like a Python dictionary where you have key value pairs, but all the keys must have the same type and all the values must have the same type. And then you're just saying, okay, give me the value that maps to this key. There's a bunch of different things you can do with map functions. And so that's here. In addition, as I said, we have XPath functions, which says, given an XML string and a path, give me information about that, about what's at that path, or return to me this value from that XML document. And every one of these has an example. If you just click on it, it has a really simple example. So here's the example of XPath. So you're going to put into XPath an XML document, and you're going to say, return to me everything that's at this path as text. So everything that's at the A/B path, return it to me. And I wind up with B1, B2, B3. And of course, I don't get any of the C's. So I wind up with this array being returned. So every one of these things, if you want to learn how to use it, there's an example. And you're right, it's pretty helpful. You also have CSV. I didn't even know this was here until last night, but you can put in a CSV string and a schema, and it will return to you a struct value. So let's see if there's an example. So select from CSV. And so here you're putting in your data, you're giving it a schema, and it's returning it to you. And there's a number of different things you can do here. Similarly, there's JSON functions. So a number of these are there to help you. And I'm going to jump actually into our product now and show you how some of these work. Okay, so let's jump into our product and talk about chocolate a little bit. So right now I am in Databricks, and I am in our Databricks SQL product. Many of you are familiar with Databricks from the data engineering or machine learning persona, which is a notebook persona. It allows you to write code in cells in Python or SQL or Scala, a number of other things, or do machine learning. You run your whole notebook, you generate results. We have this other persona called SQL. It may require a premium subscription in some clouds, but Databricks SQL looks like a SQL workbench, right? You have the ability to navigate different data catalogs, different databases, and the tables in those databases, and then write SQL on them and look at the results. You also have the ability to create charts and graphics and collect them into dashboards, to create alarms and alerts when queries, maybe you put queries on a schedule and they run and they trip some threshold and you can send an alert to Slack. You have all that capability within Databricks SQL. This is operating on the data in your lakehouse. You haven't moved data into some special new warehouse. It's the exact same data. It's a different UI. So we're going to take a look now at this. And as I said, this is based on this, this video. So first of all, let's look at arrays. Arrays resemble Python lists. So if I just say select array, I don't know. Oh, probably because I opened this a while ago. Let me re-sign in. Sorry about that. Didn't know my token would expire. Give it a second. Okay, so hopefully, let's see, I can zoom in. If I say select array, milk, dark, white, this is the array function that is going to turn this collection of items into an array. So if I pull this up here, I now see an array. So it looks like a Python list. I can also get the index of, meaning the position of something in here. So if I say what element is dark in this array, it will return to me a number. And the thing to note here is that it's one indexed, not zero indexed. So instead of this being milk is 0, dark is 1, and white is 2, in SQL, it's milk is 1, dark is 2, white is 3. So it's one indexed. I can also use this let's see, I can index into it and actually provide the position number. So I can say, give me array 0 as first item and array 1 as second item. So I should return milk and dark. I can ask for the maximum of the array and it'll do an alphabetic. I can ask for the minimum of the array. I can ask for a Boolean to say, does my array contain dark? Can I return a Boolean true or false if there's any overlap? Can I return the intersection? And so I'm going to execute all of these in one command right here. So I've got two arrays. So this is array 1, milk, dark, and white. And this is array 2, Dutch, milk, and Belgian. So let's see what happens with this. I've got a max value of white from array 1. So that's the deepest alphabetically, and a min value of dark. Does array 1 have dark? And the answer is yes. Is there overlap between these two arrays? Yes, they both contain the word milk, and the intersection, it's telling me right here, is milk. So as I said, there's lots more array functions and that you can look up in that document. So let's see what we've got going here. Now we're going to look at the explode function. What the explode function does is, if you have an array, it will explode each element of the array into its own row. So that's what we're going to do here. And now we've exploded it. So this is really helpful if you're trying to do counts, if you're trying to just transpose the array, do pivot tables, that sort of thing. I've used explode quite a bit. Okay, so moving on to structs. So how are structs different? Where an array is like a Python list, a struct is like a Python dictionary. So it's key value pairs. Now you can actually have an unnamed struct, in which case we can say select struct and say, you can give it 3 values. Let me just, oops, I lost my execute button. There we go. Let's see if we can make this a little bit bigger. Where did it go? Okay, select struct. In this case, my struct was unnamed. I didn't name my individual elements, so it created names. So column 1, column 2, column 3. I can also create a named struct where I provide the column names. And that's what's happening here. Now, once you have a struct, and it looks very much like a JSON document, right? You've got names, you've got values. Once you have the struct, you can use dot notation. So I can select this whole name struct, or I can select this named struct dot bean origin, and it will return France. So that's what's happening here. We're going to say select named struct as S, and then we're going to extract S bean origin and S ratings. So that's what the dot notation is doing here, because my data is already in a struct. Oh my goodness, there we go. Let's run. There we go. So we returned bean origin and ratings. So we've got structs and arrays, and you can have an array of structs. So every element of the array is a struct of the same shape. And within a struct, an element can be an array. And this is where everything starts getting fun. So let's look at an array of structs. So I'm going to create an array where each struct has bean origin, number of beans, and ratings. So let's see what that looks like. And hopefully you can see this. Make it a little bit bigger. So you can see I've got an array. I've got the square brackets. Actually, you can't see it all. Let me expand it. The square brackets on the end. And then there's multiple curly bracket elements in here, and each element has bean origin, bean type, and ratings. I don't know if you're aware, but within Databricks SQL, you can edit what this looks like. So right now it's displaying like that. I can have it display as text. I could have it display as JSON. And then when I go to look at this, it's going to show up like this, and I can actually navigate through it and expand it and compress it as I want. So it gives you a different way to look at it, depending on what you're trying to do, right? One might be preferable to another. But you can definitely edit how you're seeing your result. Per column, you can do this. I think I'd like to go back to the way it was, though. Let me go back to edit, and we'll change this and display it as text. Okay, so we're back to this. And believe it or not, Spark actually provides an inline function, which will convert this into an actual table. So it will flatten out everything for you, and it's called inline. So that can be handy too. If you've got an array of structs of sensor readings from IoT, where everything has a timestamp and a device ID and a value, and for some reason you want to flatten it out, this is a really easy way to do it. And of course, you can wrap stuff in control statements, if then, case, etc. So let's just take a look at that one real quick. So what this one was we've got an array of dark, milk, and white. And the case statement is when the array contains dark, then return a 5. And of course, with case statements, you keep evaluating until you hit a true. So my first one is true, so I get a 5. So I'm not going to evaluate this one. The fact that it also contains milk doesn't mean return 4. I'm gonna return the first true. So that's why we see the 5. So that's the basics of arrays and structs. Now let's look at stuff that's deeply nested. So our data source here is from Kaggle. It's called chocolate bar ratings. You could actually go to Kaggle and get this data set and create these tables. And then you'll be able to see what's going on. So let's take a look at this table here called reviews. We've got company location, which is a string, company, which is a string, bean origin, some reference number, a review date, cocoa percentage, what the rating was of that particular review, the type of bean, and bean origin. Let's see what that data actually looks like. So this is flat data. There are no structs here. But you can imagine there might be reasons why you would want these to be structs. For instance, maybe for a particular company and a particular bean type, you want a struct that has all the different reviews for that bean. Or maybe for a particular company, you want a struct that has every bean, and then for every bean, you want a struct that has every review. You could see this sort of application like in healthcare. For every patient, you might want a struct that contains every visit. And for every visit, you want a struct that contains every procedure that was done. Number of different things that you can imagine doing as far as, do you want your data to be flat like this, or would it be more helpful to have it nested? And if it's nested, how do you manipulate it? So let's take this flat data and create a nested view of it. So we're going to create 3 structs. We're going to create a struct called company, which is going to be a struct of company location and company name. We're going to create a struct called bean, which is going to contain bean origin, specific bean origin, and this other bean origin, and then the bean type. And then we're going to create a struct called review, which is review date, rating, and we're just going to create a GUID, some sort of ID over the reviews to give them unique values. And you can see I have this defaulted to JSON here. We've got, I'm gonna revert this to text so that it's a little more obvious here. Let's make this text, and we'll make this one text. And should be one more. There we go. Reviews. Make that one text. Save. Okay. So I've got company, I've got bean, and I've got review. Okay. So we haven't aggregated these yet. We've only created structs for each review, each bean, and each company. What I can do now is I can collect all the reviews into an array for every distinct company and bean. So that's what we're going to do here. We're going to do collect list of the reviews for every company and bean, grouping by company and bean. So I have the same JSON for company and bean, but now reviews have the square brackets around them. Most of them have just one review, but there's one down here, let's see, that has multiple reviews. And we could go through this, and so that's how you would create that grouping. We can aggregate one level further up at the company level and say collect list, name struct. And so we're going to collect each bean, and for each bean, we're going to have an array of reviews. So now each company is just going to have one line, and it's going to have its list of different beans, and each of those is going to have its list of reviews. So for this particular bean, here's all the reviews. For this particular bean, here's all the reviews. So now per company, you have this ability to see everything. Again, the dot notation helps you flatten it if you wanted to access stuff. So here we're going from chocolate bean stats. Let's look at what that is. So chocolate bean stats consists of two columns. One is a company struct and one is a bean struct. And I can do select, bean dot whatever, and get all that from each row. And I can also do select bean star, and that will also flatten it. Oops. Let's run that. Now, the dot operator is operating on the JSON struct. There's also a colon operator, which allows you to operate if the column is not a struct, but it's a string that represents a struct. So for instance, here I've got a string that represents a struct. Rather than try to map that into JSON and then parse it, I can use the colon operator. So I can say, first let's do a select here. And even though this looks like JSON, it's actually a string, but the colon operator will let me index into that string. So I don't have to do a direct conversion. I can just say from C1 colon price from this string. And I honestly don't understand this part of the syntax, but it's definitely part of the syntax. I don't really know what that is doing. Similarly, I can say select C1 colon, I can go deep, C1 colon item star dot price, and I can, in this case, item is an array, and I can say return the price from each element in this array, and I can get the result back. So the colon operator is also really, really handy. Now, maps are like structs, as I said, but every key must have the same data type and every value must have the same data type. It's a little bit like a lookup table. So if you have, keys that are A, B, C, and you say, okay, A maps to Czechoslovakia, and B maps to France, and C maps to Mexico. So every time you see A, you want to know what value you should sort of replace it with, or what does it look up to? What does it map to? So if I say select map and I provide it with 4 values, it's actually going to create, whoops, I didn't get the S in there, did I? It's actually going to create pairs out of those values. So it's going to say, okay, 1 colon maps to 2 and 3.0 colon maps to 4. If I put a duplicate value in there or an uneven number, it will complain because it can't pair them up. It said here it's saying there was a duplicate key. And had I put in an uneven number, it would complain. So just like arrays and structs, right, there's lots of functions you can play with maps. You can say, give me element 2. What does within my map, what does element 2 map to? And it maps to B. Return to me all my map entries. And it's saying, okay, key 1 is 1, value 1 is A, key 2 is 2, value 2 is B. You can have it return all your keys. You can have it return all your values. You can create a map from 2 arrays. So it's sort of zipping your arrays. Let's see. It's probably not the best example, but let's see. Yeah. It actually zipped these up. I guess if I had made this 5, 6, 7, we would see 1 to 5, 2 to 6, and 3 to 7. I can transform values. So there's actually some rich notation in here. And again, all of these are just taken from, if I go to built-in functions and I go to map functions and I just grabbed, I grabbed some of these examples here. All of these, like, I can say, given this map, for every key value pair, take every value and add 1. So I have some rich notation here that allows me to update my lookup table, for instance. So instead of having 1 to 1, 2 to 2, 3 to 3, I now have 1 to 2, 2 to 3, 3 to 4. That's what this notation did. I can also have the ability to add some other rich functions. So maps can also be really, really helpful. Okay, so that is maps. And then let's go to aggregations. This is where it gets really fun, especially with these chocolate reviews. So I've got this really deeply nested data. Maybe I want to keep it deeply nested, but I want to start doing aggregations and statistics on it without necessarily flattening the entire thing out. So the first thing that we do is we want to create this chocolate beans stats table, which was this one. And how did this get created from our basic chocolate reviews? So I have my reviews. I created a table called nested reviews where I basically created the 3 structs. So nested reviews was company struct, bean struct, and review struct. And now I'm going to create chocolate bean stats. And it's going to contain, we're going to select company, bean, and average rating and number of reviews from nested reviews. So I'm going to index into this to get my average review rating. And I'm going to count the number of distinct review IDs. So without flattening out review, I can still access this. Once I have this, then I'm going to create this struct that tells me for every company and a particular bean and bean origin, what was the review count, what was the average rating. And so that is what is going to come up with chocolate bean stats. So let's take a look at what chocolate bean stats looks like. So for this company, so every company, I believe, will have a line for each bean. For this bean, we can see the average rating and the number of reviews. Most of them have just one review. This one had 2 reviews. So I was able to do all this without exploding these structs. I was able to just sort of index into it and still look at those aggregate statistics. I also am now going to create a new table called bean by company, which is going to be this, and then all of these different beans collected as a list. So that's what this table is. And let's see what that looks like. So now instead of multiple rows per company, we should have 1 row per company. Up, and let's just, I guess we can just sort of, no, I'm going to change how this is being viewed. Let's make that text. Okay, and beans, we want to make text. So company, specific bean, and the ratings for it. So now if you just want to look at a particular company and you want to see all the ratings and reviews for all their beans and what was the average rating, you now have access to that through this level of aggregation. And you can still index in and get information. It isn't lost just because it's a struct. And then we can do aggregate statistics, right? So we can look at what's going on across everything. Let's just do that. Across all of the companies and all of the beans. How many companies do we have? 418. How many different types of beans on average does each company represent, etc. So, and we can start looking into that by saying, okay, how many companies have, more than 40 something beans, and tell me about those companies and what beans they have. So you have all this really, really rich capability to work with the nested data as it is, as an aggregate, as a struct, as an array, as a map, without having to completely flatten it out and then do your statistics. And all of that, as I said, again, all you have to do is come over here and find those array functions or find those aggregate functions, and work with it. There's examples for everything, and it's pretty straightforward. I'm happy to, we could try to make available these slides. You already have available this YouTube video, and I will put this in the chat. So let me come over to chat. And I see that there's a question, so let me just put, where is chat? Where'd it go? Okay, so hopefully oh, that only went to hosts and panelists. How do I make it available to everyone? I don't know how to make it available to everyone. Okay, so I see a question in Q&A which says, oh, wait a minute, here it is, to everyone, there we go. That is the link to the video. So there's a question from an attendee. Is there a reason that our data would be stored in tables like this? These functions are awesome, but trying to think about why I would be in a scenario like this. So your data is stored in files in cloud storage. And it's really up to, I think, your query pattern to help determine how you want to store that data. So if you frequently are in the business of wanting to look at stuff by company in that case, right? Maybe it's just easier to keep it as something deeply nested. Maybe it makes it easier to update things. I don't know what your specific use cases would be. I'm just trying to say, you know, certainly working through the chocolate reviews, you know, to me, I find it really useful to be able to look at aggregate statistics, right, for a particular company. How many beans, how many reviews, what was the average rating, and to be able to do that without having to flatten the data. You may find yourself in that situation. You may find yourself in a situation where everything is flat, and that's fine. But it doesn't have to be. Everybody's situation is going to be unique. Are there other questions? Okay, so I will very quickly, I just want to do a quick review of some of the resources we looked at. First of all, reviewing again, lots of training available in the coming 2 months to get you onboarded to Databricks, you and your teams. So go to databricks.com, in the left nav pane, go to learn and click on training and scroll down and you'll find these offerings. Again, the Data and AI Summit coming up in June, 4 days packed with keynotes, breakouts, technical sessions, networking, and expo. One of the best places to learn not just about Databricks, but about what's happening in the industry, what the patterns and paradigms are for the modern data stack, what your peers are doing. Talk to your account teams. There are discounts available. There are group discounts available. I believe the virtual sessions, if you're not attending in person, I think you can just stream it live for free. So be sure to sign up. One of the best uses of your time. And then again, this demo today is available on YouTube. Here's the link. It's from an old series we used to run called Data Collab Lab. There's a lot of good stuff out there. Okay, other questions? Let's see. Are there any other questions? Okay, well, with that, I will say thank you, everybody. Give you back 10 minutes to finish your lunch and get ready for the rest of the day. Thanks, everyone. Talk to you later.